Welcome. This is the last part 3 for chapter friction, which is for class 8 and subject is science. In this video, we are going to cover exercises, the question and answers that are there at the end of the chapter. It starts with fill in the blanks. Friction opposes the dash between the surfaces in contact with each other. So what does friction oppose? Friction opposes the relative motion. The motion that happens between the two surfaces, friction always opposes that. Next one, friction depends on the dash of surfaces. So what does friction depends on? Depends on the nature of surfaces. Whether it is smooth or rough, depends on the nature of surfaces. Next is friction produces dash. So what does friction produce? It produces heat. Sprinkling of powder on the carom board dash friction. So what did we see in the previous video? That if you want to reduce friction, you sprinkle powder on the carom board. So the answer is it reduces friction. Sliding friction is dash than the static friction. Sliding friction is always smaller than the static friction. Okay. Question 2. 4 children were asked to arrange forces due to rolling, static and sliding frictions in a decreasing order. So these are the different arrangements in which they arrange. Rolling, static, sliding, rolling, sliding, static, static, sliding, rolling, or sliding, static, rolling. So we have to arrange this in the decreasing order. So whichever is the highest should come first. So now let's see what is more, static or sliding. As we saw, static friction is always greater than sliding friction. So we know static is greater than sliding. And as we saw in the video 2, that rolling friction is always less than the sliding friction. So the order will be static, which is the greatest. Then it is followed by sliding and the least is rolling. So the correct answer is C, static, sliding, rolling. Okay, question number 3. Elida runs her toy car on dry marble floor, wet marble floor, newspaper and towel spread on the floor. The force of friction acting on the car on different surfaces in increasing order. So this time we have to arrange the increasing order. Wherever it is the lowest, that would come first. Wet marble floor, dry marble floor, newspaper and towel, newspaper, towel, dry marble floor, wet marble floor, towel, newspaper, dry marble floor, wet marble floor, or wet marble floor, dry marble floor, towel, newspaper. So the force of friction would be least where you have the least roughness. It depends on the nature of surfaces. So if we see here, marble floor is very smooth. Now if you put water on that, it will again reduce friction. So the least would be on the wet marble floor, followed by dry marble floor. And then we have to see whether newspaper or towel. Now if we see newspaper, the surface of newspaper is smoother. It's not as rough as compared to towel. So next will be newspaper and last will be towel. So wet marble floor, dry marble floor, newspaper and towel. The correct answer is A. Now question 4. Suppose your writing desk is tilted a little. A book kept on it starts sliding down. So we have to show the direction of frictional force acting on it. So think of this like a tilted desk. And this orange is the book. So if we keep the book on a tilted desk, how it will slide? It will slide downwards in the arrow of the green direction. And we know that the force of friction, it always acts in the opposite direction of motion. So where will the frictional force act? It will act in the upward direction, in the arrow of this, in the direction of this red arrow. So that's what I've mentioned. Book is sliding down on the desk and force of friction acts between book and desk. Friction is always opposite, so if the book is sliding downward, force of friction is upwards. Question number 5. You spill a bucket of soapy water on a marble floor accidentally. Would it make it easier or more difficult for you to walk on the floor? And why? So what would happen if you drop a bucket of soapy water on marble floor? So the answer is, it will make difficult for us to walk on the floor. Why? Because the friction will reduce because of this soapy water. So we know that we can walk on the floor because of the friction that's there between our feet and the ground. Now, if the soapy water is spilled, force of friction will reduce and will make us difficult for us to walk. Also, if the surfaces are rough, we know friction is more. But the soapy water is smooth. The nature is that it is smooth and hence it reduces friction. So the answer is, it makes it difficult for us to walk. Question 6. Explain why sportsmen use shoes with spikes. So the answer is, spikes in the shoes, they increase friction. So if friction is increased, it would give a better grip with the ground. So if a sportsman, he or she is trying to run or try to play any sports, the shoes will have more friction and hence better grip. So this will avoid slipping of these sportsmen. So that's why they use shoes with spikes. Question 7. Iqbal has to push a lighter box and Seema has to push a similar heavier box on the same floor. Who will have to apply a larger force and why? Now if we again go back to the basic, why does friction happen? It happens because two surfaces interlock. Now if the weight of the object is greater, then what happens? This interlocking also becomes strong. So more the weight, stronger is the interlocking. And if stronger is the interlocking, there is more force which is required to overcome this. So in this case, because Seema has a heavier box, so Seema has to apply a larger force. Question 8. Explain why sliding friction is less than static friction. So we had covered this in the video, but again just reiterating here. Friction happens when there are irregularities present in the surfaces of two objects which come in contact, and because of this they get interlocked with each other. Now in sliding, the time for this interlocking is very small. So if an object is sliding over the other object, there is not so much time for this interlocking to hold and hence it is not very strong. So lesser force is required to overcome the interlocking. However, if the object is static, say a large box just on the floor, then this interlocking becomes quite strong and hence requires more force to overcome. So this is the reason why sliding friction is less than the static friction. Question 9. Give examples to show friction is both a friend and a foe. We had covered this as part of the videos. Again, giving some examples. Friction as a friend. So we can walk or write with pen or even hold a glass because of friction. If friction was not there, vehicle will never stop when the brake is applied. Or even fixing a nail on the wall or tying a knot, that will not be possible if friction is not there. So These are the examples why friction is a friend. Friction is foe. Foe, or it is not desirable. So why don't we want friction at times? Because it wears out the materials. Like we see after some time the soles of the shoes cracks or screws get worn out. Also, it produces heat, it causes wastage of energy. Also, it reduces the speed of moving objects and more force is required to keep the objects going. So these are some of the examples to show that friction is both a friend and a foe. So this is the last question, question number 10. Explain why objects moving in fluids must have special shapes. So we had seen this in the video itself, why objects should have special shapes. So what happens is when the objects are moving in the fluids exerts force of friction on those objects, which is called as drag. Now the objects, for example, like a boat is moving in water, so those objects must overcome this friction in fluids, and in this process they lose energy. So we always have to minimize this friction. Now one more thing which we know is this friction or this drag, it is dependent on the shape of objects in motion. So hence these objects are given special shapes. For example, like shape of an aeroplane, which is quite similar to the natural shape of a bird. So with this we come to an end on and we've covered all the questions and answers also on friction. Thank you.